Hi, my name is Brett Rader. Today, I'm going to go through a presentation looking at the advantages of the Tetra data platform's out-of-the-box offering versus do-it-yourself solutions. A little bit about TetraScience first. We are a cloud-native data platform that is focused on providing solutions for the network of life sciences organizations that we partner with around the world. We have deep domain knowledge in that particular industry and have leveraged that to provide an out-of-the-box solution for managing your R&D data. It is a full lifecycle solution that covers instruments and applications and harmonizes that data to allow downstream analysis. We have a single interface that allows you to, either through APIs or JDBC or GraphQL, to be able to access that information. And we're vendor agnostic, being able to work with the different ELNs, LIMS, CROs, CDMOs, and analytics applications that many organizations use today. Little overview, we'll dig into this more as we go, but the point of this slide is to show that on the left-hand side, we have a lot of different instruments, software, and IoT devices that we're being asked to integrate with. We want to get that data into a data lake where we have a harmonized data model that allows us to then analyze that information through various tools and capabilities. To get the data into the right formats, we have a number of pipelines and metadata extraction utilities, QC rules, and the ability to push that information out. So that's a little bit of an overview, but why wouldn't I just build my own? I mean, AWS has a lot of tools, Azure, Google. There's a lot of things that I could use to build my own out there. So let's kind of walk through that. Well, the first thing is that you've got to connect a lot of stuff. I mean, these by no means anywhere close to the hundreds of instruments and applications that we support. So the data sources are out there, their applications, their instruments, they're coming from partners like our CROs and CDMOs. Things come from internal and external sources. Some are real time and some require batch integrations. We want to access all of that information or provide that information from all the different things we see over on the right, whether it's Tableau for analytics, Python or R for doing data science with AI and ML, or maybe it's just getting it into my LIMS system that's out there. So a lot of different things that have to be connected. I could go out and write code to do that, or use existing integration tools that maybe the central IT team or corporate IT team is using. And you could, but that's kind of like saying, I want a car, and instead of going out and buying a car, I'm going to buy all the pieces to build a car, and then I'm going to try and put that together. Now, some of you may have more luck than others with that, but that's what we're talking about here. There's some assembly required, whether it's writing code or even leveraging these out-of-the-box solutions for integration that are there. And why is that? Well, most of these vendors, actually, I'm not aware of any of the traditional vendors that actually provide connectors for things like Unicorn or Waters and Power. They provide normal things that are used in corporate IT, like a box connector or a file connector. But when we get into life sciences specific integrations that are required, whether it be for software or whether it be for IoT devices like osimeters or metabolic analyzers, they're just not there. So you would have to build those in order for you to integrate with them. And that's why these lines are in red and the X's are over. It's because they're just not there. You'd have to build it. Next thing is there's no harmonized data model. So you would have to get agreement within your organization and then implement that harmonized data model in some solution that's out there as you go about building this. Because in order for me to, in Tableau or Jupyter or say a Streamlit, to be able to analyze information across a lot of devices and applications, I need to harmonize the data and get it into a common format, or else I'm going to have a lot of work to do on the Tableau side. So I've got to get that harmonized model. Those vendors don't deliver that. They give you tools that might let you do that, but there is no harmonized data model out of the box. When I think about the next step, okay, let's say I've got a harmonized data model. I'm willing to bite that off. Now I have to set up a data lake to store all of this information because none of the traditional integration vendors provide a data lake. They give you tools to integrate with a data lake, but you'd have to set up that data lake. You would also have to then set up the Elasticsearch and Athena to be able to go and index all that and provide access to the data. And you may want to just go in and access the data and do searches and see what's going on within the data. Well, you can't do that with those traditional vendors either, because since they don't have a data lake and store any data, they certainly don't need a UI to be able to access it. So this too comes into play on something else that you would have to build in your DIY solution. And then we also have to think about, as I'm pulling data in, I'm going to need the format that data. So whether it's a Wyatt Astor report that's coming in a PDF format where I would need to translate that PDF to a common format or our harmonized format and put it in the lake, I would have to write that. I would have to write the metadata extraction and assignment algorithms to pull that metadata out of the files that we're reading or out of the systems we're reading and put that as metadata tags on the actual assets in my data lake. I would have to write the harmonization rules, the QC rules, all of that I have to write. They give me tools to do it, but you would have to write it. And then finally, I would have to write the pipelines to push that data out to my ELN or my LIMS or the data warehouse that I might be working with as a part of this. So I have to, all of these where the X's are things that I would have to go out and build within that. And then finally, if I want to access that data, maybe I want to provide some data capabilities. I push that in an RDS or a Redshift that's built into our platform. Or if I want to provide different ways to access it, as we said earlier, the traditional tools are going to give me a way to access via an API, but most of them today don't support a GraphQL or JDBC interfaces that let me take advantage of, for example, the great capabilities in GraphQL to query data that's out there, or the expected capabilities of JDBC that a lot of people rely on to hook into, say, a Tableau or a Click or whatever it might be. So those are more things that are not in that offering, but I would need to go and build out there. So let's take a look at this. You know, at the top, the costs are actually kind of like an iceberg. If I only looked at what it costs to put data into an S3 bucket, or to execute Lambda functions on AWS, for example, the acquisition cost is very low. And it fools a lot of companies into thinking, I could do this really cheap. But they don't take into account, but what they find out later is that just like an iceberg, there's a ton of cost below that waterline. And the cost to make it a platform, the integration cost, to tie all these components together and make sure that the different versions work together, to make it highly available, to handle outages, to make sure we've got the right security profiles set up, and the maintenance of the platform, as we talked about. Who's going to support the operations of this? And then who is going to advise my team on the best way to implement this, because there's a lot of stuff. So all of those costs really roll together. When we look at this slide, it's all of these pieces that are out here in the AWS stack that we use within our platform that have to be tied together. Who's going to help me with that? Who's going to maintain that? And that's where those below the waterline costs really come into play. When we think about, as we said, the Tetra data platform architecture, it's all built in. You don't have to put any of this. No assembly required. It's buying the car and driving it off the lot versus ordering all the parts and trying to put it together. So when we look at the Tetra data platform, it's an out-of-the-box solution that wraps all that AWS components up into a nice platform that you can leverage. But it's not just that. We take care of all that. We also provide the harmonized data model. We call it an intermediate data schema that already has all the data mapped into a common model and allows me to automatically map all of the things coming from the components, the CROs, the IoT devices into that model, which then leverages out-of-the-box data pipelines that will take that and put it into the data lake. So you don't have to build those either. So it's not just, our solution's not just saving you time by having a solid platform of the AWS components put together that you can leverage, but it's also having that harmonized data model and the pipelines to populate that, as well as to push data out to other sources. In addition, we have that GraphQL and JDBC access into the platform in addition to a standard API that's out there. And all the algorithms around indexing for Elasticsearch and access via Athena are baked into this solution, as well as a nice UI that allows me to go and review how the pipelines have executed, to take samples and be able to add additional metadata to that might then cause a pipeline to execute as soon as I save it. Like, for example, I review data, I say it all looks good, I can add a tag that says approved. That then kicks off the pipeline that pushes that into my LIMS system or my ELN, where I can then review the approved data that's out there. So it's much, much more than just putting together all the AWS components for you to leverage. It's all the IP around the harmonized data model, the pipelines, the UI for accessing it, and the ability to really drop this in and out of the box access it. So the benefits that we really see is that data acquisition that allows me to quickly collect the information using those out of the box pipelines and connectors to be able to deliver it. Leveraging that harmonized data model that we deliver and be able to take the data that's coming from those different sources, harmonize it, augment it with metadata, and have that go into our data lake. All the engineering and integration that goes along with the AI and ML applications, and having that data prepared so that we can leverage that. On the data management and collaboration side, how do we share data reports, analyses, and applications with those internal teams and maybe external teams, and make sure that as we distribute that research, that it's controlled, it's secured, and it has the integrity of it preserved. And then on the data science in the cloud, as we said, we are a cloud-based solution that allows us to access that data, especially in today's remote world where we all work. How can I make sure that I'm getting the right data to the right people and servicing that up? And through our cloud native architecture, that's one of the things that we allow. And so when we think about the benefits of that platform, the hundreds of integrations, out-of-the-box integrations to instruments and applications and partners that are already there, we help you actually reclaim 70% of the time you're currently spending today, or your scientists are spending today, by data wrangling. We let you reclaim that time and let them spend more time on actually performing and analyze the experiments rather than moving files around. And let you maintain that full control over the data that's moved into the platform. So as we think about DIY versus buying an out-of-the-box solution, it really boils down to our out-of-the-box solution can save you time because you're not having to put all this together and figure everything out. It's a solid choice because you're taking advantage of the industry knowledge that we've gained throughout our partner ecosystem with life sciences of bioengineering. And we think about the money that you're going to save. Time is money. And if I buy that car and I have to put it together, there's a lot of opportunity there that I'm not going to be able to go and invest in other places because I have to put this car together. Versus buying that car and being able to drive it, now I can focus my energy and resources on other initiatives versus just putting together and maintaining a platform. So as we think about the value that we're really bringing, it is that out-of-the-box capability. I can take advantage very, very quickly and not have to worry about maintaining on a go-forward basis, or I'm going to spend a lot of time actually building and maintaining the infrastructure to support my data needs.